Imagine you are in a crowded room. Everyone is calm and balanced. Suddenly, someone opens the door and pushes more people inside. What happens? The crowd is shifted. People struggle to create space again. Now imagine if the room becomes very hot, some people rush out for comfort, reducing pressure. The crowd spread out, increasing the pressure. Everyone squeezes together. That is exactly how chemical equilibrium behaves. Welcome to Latchem class. Today we are going to be talking about factors affecting equilibrium position, where reaction fight back against changes in temperature, pressure, concentration, according to Le-Chatelier's principle. Le-Chatelier's principle states that when a system is in a state of chemical equilibrium and an external constraint such as change in temperature, pressure, or concentration is imposed on the system, the equilibrium will shift so as to neutralize or annul the effect of the change. According to Le-Chatelier's principle, if the following factor is imposed on a chemical equilibrium, meaning either there is a change in temperature, pressure, or concentration, the equilibrium will fight back, will shift either to the front or to the back, so as to neutralize the effect of the change. The system is always fighting to maintain balance. So when these factors are imposed on the system, the equilibrium will shift just to maintain its balance. The effect of increase in concentration, according to Le-Chatelier's principle, if the concentration of the reactant is increased, it will cause the equilibrium position to shift to the direction where the substance is used up, meaning the forward reaction is favored. Likewise, if the concentration of the product is increased, the equilibrium will shift backward, favoring the formation of more reactants. Effect of pressure. Increase in pressure shifts the equilibrium towards the side where we have fewer gas molecules. In other words, smaller number of moles, while decrease in pressure will shift the equilibrium towards the direction where we have more gas molecule. Note that the effect of pressure is only effective on gaseous reactants. Another point, there must be overall change in number of moles before pressure can affect the equilibrium position. Looking at this reaction, the Haber process of producing ammonia. On the left-hand side, we have one molecule of nitrogen reacting with 3 molecules of hydrogen gas to produce 2 molecules of ammonia gas. If you look at it very well, on the left-hand side, we have a total 4 number of moles, while on the product side, we have 2 number of moles. So the number of moles are not equal. For in this case, pressure is effective. So increase in pressure will cause the equilibrium position to shift to the right, thereby favoring the formation of ammonia gas, while decrease in pressure will cause equilibrium to shift to the back, increasing the backward reactants. Looking at this reaction, hydrogen gas reacts with iodine gas to produce hydrogen halide gas. There is no overall change in number of moles because the total number of moles in the reactant side is 2 and that of the product side is also 2. In this case, pressure has no effect on the equilibrium position. Effect of temperature on equilibrium position. This depends on whether the system absorbs heat from the surrounding or releases heat to the surroundings. Those system or reaction that absorbs heat from the surrounding is known as an endothermic reaction, and such reaction is favored with increase in temperature, while that releases heat to the surroundings is known as an exothermic reaction. If the forward reaction is favored by increase in temperature, that is an endothermic reaction, the equilibrium position will shift to the right. But if it is an exothermic reaction, that which releases heat to the surrounding, The backward reaction is favor. Summarily, temperature increase cause equilibrium to shift to the direction where it absorbs heat. That is an endothermic reaction. If the forward reaction is an endothermic, the backward reaction will be an exothermic, which will be favored with decrease in temperature. Well done, young chemists. Always keep your mind active. Equilibrium reaction and all these ideas may seem challenging today, but with practice, they will all become second nature. Stay focused, keep asking questions, and never stop exploring the amazing world of chemistry. Don't forget to like, share, comment. See you in the next lesson. Bye.
Every day is a new chance to learn and grow with friends by our side. There's so much to know, from the ABCs to the stars up high. We're learning together, you and I.